Today, we're going to be learning how to use a TVM solver. We're not going to be learning a lesson. This is sort of an in-between learning to then be prepared next lesson. A TVM solver is a convenient and easy way for us to solve compound interest problems. We don't use a TVM solver to solve simple interest problems because we know that we just use the formula I is equal to PRT. For compounding interest, we would multiply the same values together. However, our principal value would alter. Our principal value is the principal plus the interest from the previous compounding period. We have learned to calculate compound interest using charts. However, depending on how many compounding periods there are, how many years it takes for the term to mature, it may be too difficult and lengthy for us to use a chart form to solve compound interest problems. So today I'm going to teach you how to use a TVM solver. There are many various TVM solver apps online. I have provided you with an easy to use TVM solver app on our classroom. This is the TVM solver that is linked on our classroom. We're going to go through every value here, understand what it means, and understand what numerical value we should put in for each. Let's look at example 1. Tanya buys a $1,000 GIC that pays her 4% interest per year, compounded annually for 3 years. So N is the number of payment periods. It says that her GIC is compounded annually for 3 years. So annually means once a year for 3 years. So once a year for 3 years is in total 3 periods. The interest rate is 4%. Now notice that the interest, capital I, has the percent beside it. That means that the calculator wants you to leave the interest in percent form and not convert it into decimal form. So I'm not going to write 0.04. I'm going to write 4. I'm leaving it in percent form. PV, we know, stands for present value. And it says that she bought a $1,000 GIC. So that's the amount of money she started with. So we would input where we see PV in the calculator, we would input 1,000. PMT stands for payment. In this case, we are not calculating a payment such as a car payment. So we'll leave PMT equal to 0. So there's 2 different types of compounding interest. There's one like this, where it's a GIC or a savings account, where you input money and the money grows according to the interest rate and number of compounding periods and the length of the term. But there's also compounding interest that collects interest, but then you have to pay it back. So if you borrow money from the bank or if you purchase something with a credit card, then there is interest that we learned from the previous chapter that does accumulate and it's compounded, but then you have to pay that back. So PMT in the TVM calculator stands for payments, but we're not making payments. We're trying to grow our money. So we'll just leave it as 0. Moving on to FV, We know that FV is the future value, which is what we're trying to find. So we're going to leave FV as 0. We're trying to determine how much Tanya will have in her GIC once it reaches maturity at the end of its term. So we're trying to find the future value. We'll leave FV at 0 for now. PY stands for how many payments per year. So Tanya is not continuing to invest more and more money into her GIC. She just puts in the $1,000 at the very beginning and then lets it grow. So she only made one payment. So that's why we're setting PY to equal to 1. CY is the number of times the interest is compounded in 1 year. So in 1 year, Tanya's GIC is only compounded once because it says that it's compounded annually. So I'm just going to write once per year. Okay, so that is the definition and understanding of all of the values on our TVM solver. So now what we're going to do is we're going to input them into the app. So n is equal to 3. So I'm going to delete 0 and input 3. I is 4. I don't need to write any units. PV, present value, 1,000. PMT, we're going to leave as 0. Future value, we're going to try to find future value, so I'm going to leave it alone for now. PY is already set at 1, and CY is already set at 1. So now I'm going to go over here and I'm going to click Solve for Future Value. Now notice that we get a negative value for our future value. That is because the TVM solver distinguishes between money received and money given. So right now, the calculator thinks that you owe the bank $1,124.86. The TVM solver is automatically assuming that you took out a loan of $1,000 and this is how much you have to pay back now with compounding interest. So to fix that, I'm going to go back to my PV value and I'm going to input a negative there. Delete all this. And now I'm going to solve for FV again. And notice that it's the same value, but just positive now. So I've inserted this negative sign in my present value to indicate to the calculator that I gave the bank $1,000. I didn't take $1,000 from the bank. In this case, I gave the bank $1,000 for the bank to grow my money. And so at the end, the calculator now understands that this is how much you're going to receive back. Okay, so if we were borrowing $1,000 from the bank, then we would delete this negative so that the computer understands that we received $1,000 from the bank, and then it would generate a negative value for FV, which would indicate the amount of money we have to return. If this is a savings question, that means that your PV has to have a negative value for you to get a positive FV value. But if you are borrowing money, then your PV would be positive and then your FV would be negative. So here we've initially got a negative value. But now that we understand how the positive and negative values work in the app, we fixed that and we received a future value of $1,124.86. Example 2. Jamil invests $1,000 that pays him 5% interest per year, compounded semi-annually for 2 years. So again, he is investing. He's not borrowing, he's investing. So automatically I know that when it comes to my PV value, I would input a negative. So it's asking us to underline 4 pieces of important information from the question. So I'm going to take my ruler out. And what's important is his present value. How much does he begin with? And the interest rate is important. And the number of compounding periods per year is important. And how many years it takes for the term to mature is important as well. So remember that N stands for number of payment periods. So it's compounded semi-annually. So that means it's twice a year for 2 years. So in total, that's 4. Our interest rate is at the capital I. In percent form. PV stands for present value, which is 1,000. No units. PMT stands for payment, which we're going to set to 0 because Jamil has not borrowed money from the bank. He doesn't need to pay them back. He's investing. FV stands for future value, which we're trying to find. So we're going to skip for now. PY stands for payments per year. Since he's investing one time, he pays once. And CY stands for compounding periods per year. And it says at the top that it's compounded semi-annually, which means that it's twice a year. Okay, so we have taken in account all 4 pieces of information that we underlined. So now we're going to input all these values into our TVM solver. So N is 4, Y is 5, PV is negative 1,000. PMT we'll leave at 0. FV we're trying to solve for, so we'll skip. PY is 1, which is already set there. And then CY is 2. And go over here and push solve for FV. This is the amount of money that will be in Jamil's account after 2 years. There are 4 practice questions at the bottom of the last page that I encourage you to complete independently right after this lesson. Please reference my answers to ensure that you have the correct answers and that you fully understand today's lesson. Message me if you have any questions.